In this video, we want to look at the equation of a circle, how to find it and how to use it. And first, what I could say, imagine you have this point, and it's the point AB. And imagine around that point, we draw a circle. It has a radius R, and the center is AB, like we started with. If you imagine any point on that circle, we can say is the point XY. Coordinate X, coordinate X, and Y coordinate Y. Well, if you look at this little triangle here, we can make a right angle triangle very easily out of that. And you can see that any point X on the circumference will be the height and the width of that triangle. Well, the width is going to be X, take away whatever A is, X coordinate, take away A coordinate. And the height of that triangle will be Y, take away B. So this is X minus A, and this is Y minus B. But it's a right angle triangle. So Pythagoras' theorem then says that, okay, the hypotenuse squared R squared equals X minus A all squared plus Y minus B all squared. And that's what we have here. And that works for any point on the circumference of that circle. And so the equation of any circle centered at AB and with radius R is this: X minus A all squared plus Y minus B all squared equals R squared. This is a general equation of a circle. X minus A all squared plus Y minus B all squared equals R squared, where AB is the center of the circle and R is the radius. Now, one specific time here is when we have the circle is the origin, then this becomes much easier because A and B are both 0, so it simply becomes X squared plus Y squared equals R squared. So if you have a circle centered at the origin, it's just X squared plus Y squared equals R squared. And we can move that on slightly. So imagine here's our formula for the circle. R squared equals X minus A all squared plus Y minus B all squared. If we simply just square out these brackets, then X squared minus 2AX plus A squared and Y squared minus 2YB plus B squared. And a little bit of rearranging there, nothing too much. First of all, let's take the R squared over to one side and put it equal to 0. And then we'll bring the squared terms together, so X squared plus Y squared. We'll bring the X and Y terms together, minus 2AX minus 2BY. And then we have these A squared, B squared minus R squared at the end. And so what we can also say then is the general equation of a circle. If we put it equal to 0, X squared plus Y squared minus 2AX minus 2BY plus some number, plus C. And that value of C is just all of this stuff put together. So it's A squared plus B squared minus R squared. And so sometimes you'll see the equation of a circle written in this form, rather than written in terms of squared brackets. We expanded this out to get this general equation. To go backwards, what we would do is we'd complete the square. And we'll see that in some of the examples that we're going to look at. So here's one to start with. Find the equation of the circle with center 3 minus 1 and radius 4. Well, our center is AB and R is 4 here. So all that we can simply do is say that, okay, X minus A all squared plus Y minus B all squared is equal to R squared. And we just need to fill these values in. A is 3, so it's X minus 3 all squared. Y is minus 1, so it's Y minus 1, so Y plus 1 all squared. And R is 4, so that's 16. And hey presto, that's it. That's the equation of a circle with center 3 minus 1 and radius 4. I guess if we wanted, we could square these brackets out. And when we do that, we get X squared minus 6X plus 9 plus Y squared plus 2Y plus 1 equals 16. And if we just rearrange it, move things around, X squared plus Y squared minus 6x plus 2y plus 9 plus 1 minus 16 equals 0. Or x squared plus y squared minus 6x plus 2y 10 minus 16 is minus 6 equals 0. And so we also have it in the general equation written in this format too. Either of these, unless you ask for a specific format, either of these is an absolutely fine answer. So we saw, if we're given the centre and radius, how to work out the equation of a circle. How do we do it in reverse? Well, looking at this one, x squared plus y squared, x squared plus y squared plus 2x minus 4y minus 4 equals 0. There's a couple of ways we're going to do it. And the first way I want to look at it is by completing the square. So I'm just going to rearrange this slightly. I'm going to say that's x squared plus 2x plus y squared minus 4y minus 4 equals 0. So put all the x terms together and all the y terms. And if I look at the first bit there and complete the square, and that's x plus 1 all squared minus 1. If I then look at this next bit, the y terms, and complete the square in them, well, that's y minus 2 all squared minus 4. And we've still got this minus 4 equal to 0. And so when we tidy that all up, we get x plus 1 all squared plus y minus 2 all squared minus 9 equals 0, or equals 9. And when we compare that then with x minus a all squared and y minus b all squared equals r squared, then it's easy enough to see then the centre of a circle, a must be minus 1, b must be 2, and r squared is 9, so the radius is 3. Now, I quite like this way of completing the square to find your values of a and b, because when you do that, you immediately find out what r squared is, and so it's very, very easy to find what r is. There is another way that we can do this, and this is just by looking at this original equation. So let's try that. So let's go back. The original question then was x squared plus y squared plus 2x minus 4y minus 4 equals 0. And if we compare that with our general formula, which we've said is x squared plus y squared minus 2ax minus 2by plus c equals 0. Well, we can see then we've got the same number of x squareds and y squareds, great. But if you look at the x terms, on top we have 2x's, and on bottom we have minus 2ax's. So what I can say is 2 must equal minus 2a, or a equals minus 1. And looking at the y terms, well, on top I have minus 4y, and in the blue on the bottom one there I have minus 2by. And if minus 4 is equal to minus 2b, then b equals 2. And so immediately we get that a is minus 1 and b is 2. So the centre is minus 1, 2, is AB. And so in this way, you much more quickly get the centre of the circle. However, we do have a wee bit of work to help to find the radius. It's not hard, but we need to work it. And it's this value of c then that we're going to look at. And c is the number on its own at the end, which in this case is minus 4. And I know that c is equal to a squared plus b squared minus r squared. So we're just going to fill in for that. C is minus 4. Well, if a is minus 1, a squared is 1, b squared is 4, and minus r squared at the end there. So r squared equals 9, and so the radius is 3. And that's exactly the same answer as we got the other way. I think completing the square, the advantage of that is that you find the radius almost immediately. It takes a wee bit longer just to complete the square and find what A and B are. In this method, you find A and B almost immediately, but there's a wee bit of work to find the radius. And also you need to remember what C is equal to, A squared plus B squared minus R squared. So one last example here. It's a wee bit stranger in this. 9x squared plus 9y squared minus 12x plus 18y plus 4 equals 0. Now, first thing, is it the format for the equation of a circle? Well, it has an x squared term, a y squared term, an x, a y term, and a number term. And we have the same number of x squareds and y squareds. So in that case, what we can do, because it's equal to 0, we can divide every term by 9. And when we do that, we get x squared plus y squared minus 4/3 x plus 2y plus 4/9 equals 0. It is in the format of the general equation of a circle. If there was an xy term in here, look, there's no mixing of the x's and y's here. There's no xy term. If had there been an xy term, then immediately, without even trying any calculations, we'd be able to say, no, it's not the equation of a circle. Now, having got this to x squared plus y squared, I'm going to complete the square on it again. So let's, I'm just going to reorganize it first. So x squared minus 4/3 x plus y squared plus 2y plus 4/9 equals 0. Well, on the x terms, then x minus half of that x term, so it's 2/3 x all squared minus 2/3 all squared, so that's minus 4/9 plus, well, y plus 1 all squared, take away 1. And then we've still got the plus 4/9 on the end equals 0. Oops, I'll spot the mistake. It should be just minus 2/3. Again, just tidying up a bit. X minus 2/3 all squared plus y plus 1 all squared is equal to, which just equals 1 when we take it to the other side. And so the centre of the circle is, again, let's compare it with x minus a all squared plus y minus b all squared is r squared. Well, the centre of circle, A must be 2/3 and B must be minus 1. If minus B is 1, B is minus 1. And if r squared is 1, then the radius itself is just 1.